Hey guys, chapter 7 video here for you. We are starting our first topic, so 7.1. In this video, we're going to work on how can I identify and name polynomials. I love that word, polynomials. It just sounds fun to say it 3 times fast. Polynomials, polynomials, polynomials. We're going to learn how to name them and identify them. So we'll kind of get it. We're probably going to have to organize a chart in our notes to kind of show you how to do this. And it might not make a lot of sense at first, but I hope by the end of the video you're kind of following along with me. So this is an example of a polynomial. It's really just an expression. 4x squared plus 3x minus 7. Now we can't solve it. There's no equal sign. There's nothing for us to solve, nothing really for us to do right now. But I do want to name some parts and pieces of this expression. So first off, you see there are 3 things. There's a 4x squared, a 3x, and a minus 7. We call those terms. There are 3 terms in the expression. We also notice that there are numbers in front of the variables. There's a 4 with the x squared, and there's a 3 with the x, and those are called coefficients. Coefficients are the numbers with the variables. Now that minus 7 doesn't have a variable, so we call it the constant. It's the number that doesn't have a variable, the constant. So we've got terms, we've got coefficients, and we have constants. But the whole entire thing as a whole is just called a polynomial. It's made up of many terms. So what we're going to do today is define some things. What is a polynomial? Well, technically it's expressions that are made of terms, constants, variables, and exponents. So you put a whole bunch of variables and numbers together and some exponents and you've got a polynomial. Now, there are names for special types of polynomials. We don't name every single one of them because there are millions of these. But we have special common polynomials that have names for the number of terms. So I'm going to teach you some of those names today. So names are just for the special common polynomials, the ones that people use the most frequently or see the most frequently, so we give them special names. So we're going to get into those special names, and the way we're going to do it is we're going to create a chart with 3 sections. It's going to be pretty big, so use a lot of space in your notes. In the first section, we're going to have examples. In the middle, we're going to talk about what the degree is. I'll explain that in a few minutes. And then we're going to name it. So we're going to have an example, the degree, and the name. Okay, so let's try our first one. We're going to start off with the easiest one, which is just a number. So we're going to write 7. Now, 7 is a number. There's no variable. It is what we call a 0-degree problem. And like I said, I'm going to explain that in a minute. And when we name it, remember we call it the constant. It's a number by itself. It doesn't have a variable. So I could use any number for my example. I didn't have to use the number 7. I could use 3 or 5 or negative 10 or 2.478. Doesn't really matter. As long as it doesn't have a variable, then we say degree 0 and a constant. But let me show you one with a variable, 3x. Now 3x is a little different. 3x is what we call a first degree problem. And the reason is because the x technically has a first power. We don't usually write the little 1 power. That would be wasted space. But because of that power, we call it a first degree problem. And if you wanted to really get technical, that 7, we could have put an x with it, but it would have been x to the 0 power. And that 0 power is why we call it a 0 degree. So just giving you kind of a little background there. So the degree is related to the powers, the exponents. If you have no powers, it's like having a 0 power. That's your degree. But if you have an x, then it's like a first degree. Here's another example of a first degree problem. 6x minus 5. Now, I know the minus 5 is a constant, but if you look at the whole thing, 6x minus 5, x is to the first power, so it counts as a first degree problem. Okay, so 3x is what we call a monomial because there's only one thing. Mono means one, so monomial means there's only one term. So I'm going to circle mono here for a minute. 6x minus 5 has 2 terms, so we don't call it a monomial, we call it a binomial. Think of like a bicycle. I'm sure you've ridden a bicycle before. How many wheels are on a bicycle? 2. Bi means 2. So if we have 2 terms, we call it a binomial, just like a bicycle. So both 3x and 6x minus 5 are first degree problems, but one of them's a monomial and one of them's a binomial. That's the difference between them. but they both get categorized as a first degree. Let me show you a second degree problem. Here is a second degree problem. Why do you think it's called a second degree problem? Yeah, it's 5x squared to the second power. That's why it's a second degree problem. Now 5x squared is a single term. There's no plus or minus anything. It's just 5x squared. So it's still considered a monomial. There's only one term. But let me show you another example. X squared plus 4x. What is the highest power in this problem? X squared. X squared means it's a second degree problem. That's the highest power. How many terms are there? Oh, there's two, x squared and 4x. So it's a binomial with two terms at a second degree power. How about this one? 5x squared plus x minus 4. What's the highest power? X squared. Still a second degree problem. But how many terms are there now? There are 1, 2, 3. 5x squared, x, and negative 4. That's a three-term problem. So it's not a monomial. It's not a binomial. What do you call a bicycle that has three wheels? A three-wheeled bicycle is called a tricycle. So we're going to call this a trinomial. Because of those three terms, it's a trinomial. So we have monomials with one term, binomials with two terms, and if we have three terms, we call it a trinomial. But all of these last couple of examples have x squared as their highest power, so they're second degree problems. Okay, let's draw a line under that. I'm going to move this chart up. Let's look at a third degree problem. What do you think a third degree problem is going to have? Sure enough, x to the third power. 5x to the third power plus 7 is a third degree problem because 3 is the highest exponent or the highest power. Now, how many terms are in 5x to the third plus 7? Well, there's two. There's 5x cubed and there's 7. So this is what we would call a binomial because there's two terms. I'm going to show you another example here. X to the third plus 6x squared minus 9. That is a third degree problem. X to the third is the highest power. How many terms are there? There's 3. X to the third, 6x squared, and negative 9. That means it's a trinomial problem. What about this one though? This is a third degree problem. 8x to the third power plus 2x squared plus x plus 1. How many terms are in this problem? 1, 2, 3, 4. 8x cubed, that's 1, 2x squared, x, and 1. So, have you ever ridden a bicycle with 4 wheels? Yeah, I guess you could call it like a quad, right? But at this point, what we call it is a polynomial. Now, the word poly means many. So it just means there are many terms. Once we get past 3 terms, so we have that monomial, binomial, trinomial, after that, we're going to call it a polynomial. If there are 4, 5, 6, 7, 8, 9 terms, then we're just going to categorize that as a polynomial. All right, let's draw a line. Let's look at a fourth degree problem. So what will a fourth degree problem have? Of course, it'll have an x to the fourth power. So 9x to the fourth power is a fourth degree problem. But what is its special name? Is it a monomial? Is it a binomial? Is it a trinomial? Or is it a polynomial? Well, there's only one term, so we call that a monomial. All right, so let's look at our big table that we've made. Here it is if we zoom back out. I hope you have some nice looking notes now. So we've talked about degrees. So the degree is what we call the highest power. So if there's no power at all, we call that a 0 degree. If it's a first power, then you just have a single variable. Second power means it's squared, and third power means it's cubed, and fourth power means it's to the fourth power. The name is related to the number of terms. So it's either a monomial, a binomial, a trinomial, or we just categorize it as a polynomial. And our table can continue on. There are 5th degrees and 6th degrees and 7th degrees, and it goes so on and so on. And there are actually special names for those, but for the most part, I just call them 5th, 6th, 7th degrees. I try not to remember all the special names. It gets a little cumbersome. But here's something you also can add to your chart. When we're talking about a first degree problem, we call that linear. That's y equals mx plus b. Linear problems are first degree problems. Y equals mx plus b. There's a single x to the first power. That's linear. When we get into second degree problems, the graphs and the functions that we're going to be talking about soon are called quadratic problems. So those are quadratics. When you get into the third degree problems, we call those cubic problems. That's why we say 5x to the third is 5x cubed. Cubic is what we call the third degree. And technically we have names for the other degrees too. So fourth degree is called the quartic degree. I gotta admit, like a lot of people don't remember that name quartic, but I always think of a quarter, like there are 4 quarters in a dollar. So quartic, that's how I remember it. And we can name the 5th, 6th, and 7th, and 8th, and 9th, and 10th degree, and so on, but it's not really necessary. These are the ones that would be nice to know, that first degree is linear, second degree is quadratic, and third degree is cubic. I would say those 3 are very important. Okay, so now let's try a problem with all this information. Keep that chart handy. We're going to go back and look at it when we need it. Here's our problem. We are going to simplify this crazy looking expression. So we're going to write this down in our notes. Big parenthesis, p to the third plus 5p squared plus 9p minus 6 plus parenthesis, negative 5p to the third minus 8p plus 1. All right, so we can't solve for p. There's no equal sign. There's nothing we can solve for, but we can clean this up. It's pretty messy. We've got 2 parentheses, but do we have any distributive property going on here? Anything we need to multiply? No, no distributive property. So really those parentheses I didn't actually need. They're kind of unnecessary, but here's what I'm going to do. I'm going to put like degrees together. I'm going to put the p to the third and the negative 5p squared together, and I'm going to cross them out so that I can keep track of what I'm putting together. I'm going to put the plus 5p squared by itself, I think. Isn't that the only p squared? Do you see any others? I do not. Then I'm going to put the plus 9p, and I'm going to put the negative 8p together because they're the same degrees. And then I'm going to put the minus 6 and the plus 1 together. And as I'm doing this, I'm crossing them out so that I keep track of everything. So now I have all the same pieces, all the same terms, but I've rearranged the order. And I'm going to combine my like terms. P cubed minus 5p cubed would be negative 4p cubed. Let's see. 9p minus 8p would be 1p. Negative 6 plus 1 would be negative 5. Now the only thing I didn't do anything with is this 5p squared because it didn't have anything to combine with, so it's still there. Now check this out. My simplified answer is negative 4p to the third plus 5p squared plus p minus 5. And that's it. That's my answer. Now could I take this farther and do anything with it for like an advanced score? Totally. I could name it. I could give it that complicated name. What is the name of this expression? What's the highest power? It's third power, p to the third. So here's how I'm going to name it. It is, because of that third power, a third degree problem, which we call cubic. It's got 1, 2, 3, 4 terms on it. So it's called a polynomial. Third degree cubic, let's name it polynomial because of those 4 terms. And that's it. That's its name, third degree cubic polynomial. Imagine just using that casually in a sentence. What were you doing in school today? Oh, we were just studying third degree cubic polynomials. so nonchalantly, right? Third degree names its power, cubic is its type of graph, and polynomial is how many terms it has. All right, so we've got our answer, we've named it, we're ready to move on now that we've figured that piece out. So let's have you try now. I'm going to have you simplify and name this expression. Here's your expression, big parenthesis, negative 2x to the fourth plus 3x minus 5 plus parenthesis 7x minus 1. Right now, hit the pause button, simplify, and name it. Go. All right, you ready to check your answer? Let's see how you did with this. So we are going to rename this. I don't see any distributive property. I looked real carefully. There's nothing in front of the parentheses. So I'm just going to reorganize this a little bit. Negative 2x to the fourth looks like it's all by itself. I'm going to cross that out. 3x, I'm going to cross that out. Could go with the 7x. They match up. And the negative 5, we'll cross that out. Can go with the negative 1. And we'll cross that out. Now there's all my parts and pieces. Now let's combine like terms. So 3x plus 7x is 10x. Negative 5 take away 1 is negative 6. And then that negative 2x to the fourth is kind of by itself. But there it is. There's your solution. Your simplified answer is negative 2x to the fourth plus 10x minus 6. Is that what you got? Now let's name it. What's its highest degree? Well, it's a 4th degree problem, which we call quartic. It's got 1, 2, 3 terms, so we call that a trinomial. So it is a 4th degree quartic trinomial, and that would be the name of this expression. All right, I hope you did good with that. Let's try another example now. So same directions, we're going to practice simplifying. This time, here's what we're going to simplify. Big parenthesis, t squared minus 6t plus 3 minus negative t squared plus 9. Now, what's different in this problem compared to the last two? It's a subtraction problem. It is not an adding problem. And because of that subtraction, we have to be so careful. We have to subtract everything inside that parenthesis. So it kind of is like distributive property. We have to subtract the negative t squared and subtract the 9. That means I'm going to have a plus t squared, because that minus minus turns into a plus. And then my plus 9 actually reverts into a negative 9, a minus 9. So we got to rewrite this problem. Now, the first part of the parenthesis, t squared minus 6t plus 3, nothing changed there. But it's plus t squared minus 9. And now I can put my like terms together. So I see a t squared and another t squared that I can cross out and put together. I see a negative 6t, but I don't see anything that can go with it. I see a plus 3, I'll cross it out, and a minus 9, I'll cross it out. There it is, all rearranged, all the parts are together. Now we simplify by combining, so t squared plus t squared is 2t squared. 3 minus 9 is negative 6, and then that minus 6t is kind of by itself. So there it is, there's our simplified expression. 2t squared minus 6t minus 6, and we've answered the question. But what's my level for advanced work? I'm going to name it. What's the degree of this problem? Well, highest power is the second power, so it is a second degree. What do we call that? You got to look at your chart probably. We call that a quadratic. Second degree quadratic, and then how many terms are there? There are 3, so it is a trinomial because of those 3. Second degree quadratic trinomial. And we've named it and we're done. All right, let's have you try. Here is your you try problem. Simplify 5x squared plus 3x minus 7, take away 6x squared minus 2x minus 7. So same story, simplify and name this thing. Go ahead and hit the pause button and try your best. All right, you ready to check your answer? Let's see how you did here. So first off, I hope you took care of that minus sign and I hope you distributed it in. Meaning we're going to have a minus 6x squared, a minus 2x becomes a plus 2x, and a minus 7 becomes a plus 7. That's the first step, rewriting. Now the beginning stays all the same, 5x squared plus 3x minus 7. But now we put our terms together that match. So 5x squared, cross it out, is going to go with the negative 6x squared. Those can go together. The plus 3x, cross it out, goes with the 2x, cross it out. And the minus 7, cross it out, goes with the plus 7, cross it out. Now we've got all of our like terms organized and we combine. 5 take away 6 is a negative x squared. 3x and 2x make 5x. And negative 7 plus 7 make what? Make 0. Okay, so those are going to go away. So my answer is just negative x squared plus 5x. But let's name it. It is a second power degree, so it is a second degree problem, which we call quadratic. It's got 2 terms. We call that a binomial because of those 2 terms. So it is a second degree quadratic binomial. Again, you can say that so casually. Oh, it's just a second degree quadratic binomial. Sounds so easy, right? All right, so how did you do? Did you get the same answer as me? Did you name it correctly? Did you make any mistakes in your process? Notice my work. Look at the page right now, or the screen. Like every step is shown as neatly as I possibly can so that somebody else could read my paper and kind of follow along and figure out what I am doing. My answer's clear. I've boxed it. I've drawn arrows. I've crossed out my terms. I'm just trying to be neat and organized. So please make sure your work looks similar to mine. Okay guys, so that wraps up our video. Just to kind of refresh your memory here, a polynomial is an expression that has terms and constants and variables and exponents. And then we have special names for special common polynomials. So we talk about the degree and the number of terms. Thanks for watching, guys. We're going to practice this in class. Bye.